Good afternoon. If those of you coming in would please take your seats so we can get started. We know we're running a little behind, and we appreciate that you have all hung in for the end of the conference, and you even came in from outside after being down in the basement for 2 days. I'm Betsy Olnick Dougherty. I am a board member with ANFA, and I'm an architect practicing here in Southern California with my husband Brian, who you have already met. And it is my job to first state the problem. Now, as an architect, I kind of have a problem with the word problem, personally, because we are looking for solutions, right? And we are not necessarily just problem solvers, but opportunity makers. And I can't think of a better way to search for those new opportunities than with a neuroscience partner. It has been a terrific opportunity for me to be sitting in a room with half architects and half neuroscientists, and I've never felt so stupid in my life. I'll give you a brief introduction of my own history with ANFA, which really began with Jonas Salk. One of the things that hasn't been said is that Jonas actually served as a public member to our National AIA board. There is such a position. He served on the board for 2 years, and I had the great pleasure of being a board member at the time representing California. And what a rare opportunity to get to know Jonas on an interpersonal basis. And of course, he never ceased to inspire us all. Every word was a word of wisdom. And he very gently, in his own very polite way, and I think Peter's an extension of that, challenged us as a profession at that board as he was departing after 2 years and said, I love architecture, I love what you do, but it's a bigger question. And he referred to his own partnership, of course, with Lou Kahn, and really challenged us to expand the way we see and approach architecture and the design of the built environment. And it was a very gentle prodding. We still gave him the 25-year award. And of course, we were here in San Diego, at which time that legacy project that Alison Whitelaw referred to was executed. And I had the great pleasure of, as a member of, at that time, the College of Fellows, I was vice chancellor that year, that the project for ANFA was recognized with the second La Trobe Fellow. And for those of you who don't know, that's a $100,000 grant given over 2-year time. So this was the second grant given. There was an AIA grant the following tenure as well that was given from the grants program. So this was really the beginning of ANFA, and of course I had gotten to know John Eberhardt through AIA, and John and I went out to lunch, and by the end of the convention I was on the board. That's kind of how that came down. So he did draft me in 2013. It's hard to believe that that much time has passed, but it was a great compliment to my own long-term commitment to the profession of architecture. And this is the meeting of two disciplines. It is fascinating, truly art and science, just as we were provoked by Jonas so gently. And as an architect, I think we all felt that this is beyond intuition, because we intuitively might know something, but to think that it can be proven and that there can be value in that and that can improve the quality of life is pretty powerful stuff. And of course, the partnership between Jonas Salk and Lou Kahn was the ultimate example of that for the rest of us. And it showed enrichment of collaboration. And we collaborate with a lot of people in our work. Brian and I, as Dougherty and Dougherty, focus on educational facilities. They have intrinsic value. They can change lives. We truly believe that, as corny as it may sound. But the reality is, and we always talk about the fact that we are steeped in reality when it comes to the design of educational facilities, because we are operating within a socio-economic political environment that's highly regulated. There's never enough time. There's never enough money. And there's a lot of expectation. So this particular building type is ripe for the collaboration, but it really has its challenges in terms of being able to execute something that can be very personal and powerful and have that impact upon people. No question about the fact that it has everything to do with quality of life issues in any community. So applying this research and finding means of implementation is my interest, which is why I came onto the board. As an architect, it's not just enough to talk about theory, but it's to talk about application and implementation. and have an informed contribution to the design process. So it is a great pleasure for me, of course, as a person with a long-term history with AIA, to be here to introduce a very select group of speakers. And these speakers are representing the AIA Committee on Architecture for Education. They meet frequently, they've traveled the world on the subject, and it should be a very interesting and worthwhile conversation, so thank you for being here. And with that, I am going to introduce Claire Gallagher, who will then introduce John Dale and take it from here. So Claire.
Thank you.
Thanks, Betsy.
Thank you, Betsy. I am Claire Gallagher, and I think I would like to tell you what my connection to ANFA is also, and it's John Eberhard, who's sitting up here. He's my mentor. I taught at Carnegie Mellon University when he was the head of the School of Architecture there. And from that time until now, I've lifted that foot up and put the other foot down into teaching in a school of education. So I'm seeing this now from a very different perspective. It was much easier teaching design than teaching in a school of education. So with that, we will begin. So schools are complicated, but the outcome is what all of us are interested in, both in the audience as well as on the panel. There are numerous variables, complicated social interactions, pedagogical concerns. I'm interested in the intersection of pedagogy and school design. There are political implications, but there are some schools that appear to work. And in the world of architecture, we all know what work means. To explain that to someone who is not in design is a very difficult thing to do, but we know what it is to have schools that work. We don't know really why this happens. There are some instances that I'm going to call two of them out here that you can see. I think we would agree they work or they don't work, but we're wondering if this can be intentionally designed into a building. So from a historical perspective, Crow Island School is one example that everybody brings up constantly, both in the history of education as well as in design, as a school that works. The flip side, and you hear this a lot in schools of education, the open classroom. It failed. Why did it fail? And there are a number of articles that have been published recently about the fact that we are now reintroducing the idea of the open classroom. At least that's what the people in education are saying. Why are we doing this? So in the successful spaces for learning, we feel that there's an apparent resonance between the pedagogy and the school design. And John Dale and I co-chaired the Committee on Architecture for Education's Design Awards this year. And in looking at the projects, the successful projects, to give a presentation after the fact, we had this epiphany that the schools that we found that were successful were the ones where there was this apparent resonance, where there was an appropriation of space, and where there was this seamless, it appeared to us, a seamless connection between the spaces and what was happening there. So rather than the teachers or the educators teaching around the building, they were teaching with it. So in the unsuccessful designs, there's an inherent dissonance, we feel, between the spaces and the activity within them. The example on the left was obviously schematic, but an open classroom design where in the text that goes with this drawing, you can see where the first wall was built. And that is a response by the educators in the spaces that the dissonance is so apparent to them that they begin to change the spaces, whether it be to put up a wall or in the case on the right, covering windows, which happens a lot. Something to consider, and I just would like to throw this into the conversation at some point today, that children have very strong ideas about school. There was a project in 1960s, and again in 2003 in the UK, where children were asked to contribute their ideas about school. And the project was called The School I'd Like. And the parallels between what happened in the 1960s and what happened in the early 2000s was just unmistakably interesting. The children were very strong in stating things that were more experiential than anything else. And the example on the left was drawn by, I think, an 8-year-old, where the school was a planet, and it was described as a listening school. The school on the right was school as community, and they describe a lot of caves for learning, and round spaces. And I'm convinced at this point that that may have more to do with hierarchy and their desire for a lack of hierarchy than anything else, to be equal. These are some of the reflections, and to me, I think the more interesting part about this is that they want to see themselves as equals with the adults in the spaces, and they want to have choices in the spaces. I think that the second quote here is particularly interesting in that they envision a lot of nature. They talk about wanting to have animals in the spaces. They talk about wanting to be able to be inside and outside. They talk about having to be able to see and be seen in the spaces.
Okay. So it's been very interesting to sit through a whole range of very different kinds of sessions. And there has been an interesting theme about the sometimes evident dichotomy between the very specific work that neuroscientists do in understanding how the brain is functioning, and architects who like to speak in more global terms. And I have here some quotes which I think indirectly deal with the complexity of the issues we're dealing with and suggest the need for further adjustment and further conversation between those two poles to really start to get right the kind of research we need to do. This happens to be a couple of quotes from a book about building a Waldorf school. And if any of you know the Waldorf movement, it's an international movement of independent schools founded by Rudolf Steiner, who was an architect, among other things. And the spirit and the pedagogy of the school is very much a balance of body, mind, and spirit, and a very strong sense of both the spiritual and physical development of children at different ages and needing to respond to that physically. So the first quote is that children actually experience all of their surroundings, room, wallpaper, furniture, colors, and even the air in the classroom. All this can be either friendly or oppressive. Above all, the builder seriously considers the child and what he experiences while in school. Now, the second one I want to point out is talking, interestingly enough, about both symmetry and asymmetry. And I think some of the researchers have presented ideas that are very specific about the utility of symmetry, and others have talked about a more random experience. So they're combined here. When the child encounters asymmetry, he must find an equivalent in another place. He experiences in his feeling the path leading from one to the other. In the symmetrical, he experiences, without effort, a static balance. In asymmetry, he produces this balance through his own activity, thus establishing a dynamic equilibrium. This interplay of the statically given and the dynamically achieved symbolizes in architectural form the child's experiences in the school community. On the one hand, things come to meet him, while on the other hand, he must contribute something to the life around him. So that's just, I'm offering that out as food for thought. I want now to briefly introduce our panelists. We have a very distinguished and varied group of panelists who are educators, researchers, scientists, architects, and we think we have a wonderful diversity of viewpoints here. So we have Alan Dunlop from Scotland, who is here as an architect who has produced a wonderful educational environment, which is getting very specific responses, a school designed primarily for people with severe disabilities, but notably children who are blind or deaf. We have Dieter Breithecker, who is from the Federal Institute on the Development of Posture and Exercise in Germany, and he is really thinking about the individual in his or her space, and being at a state of comfort and high consciousness. We have Lennie Scott Weber, who is both an educator and researcher who is now with Steelcase, who is really looking at the scale of an individual classroom at how reconfiguring it can lead to dramatically different results in learning achievement. And Peter Barrett from Salford University in England, who has done a remarkable and rigorous piece of research looking at what happens in 70 classrooms and trying and distilling very carefully the different elements that create the environmental experience, whether it's color, natural light, ventilation, and so on. And then we're very pleased to have Karen Dobkins with us. Karen being a neuroscientist here at the Salk Institute, and she is going to give her perspective on the various examples of research and reflection that we're talking about today. So I'm going to let each of our panelists speak briefly, we hope briefly, to give some viewpoints, and then we have a series of questions that Claire and I are going to ask, which our panelists are all aware of. And we want to get to the point where we can open it back out to you. So we hope this will be 1/3, 1/3, 1/3. We'll see how it goes. So, Alan, would you like to come and speak?
Hello. Looking around, obviously, the Salk in 2014. It's the guy with the tie that's the real loose cannon. I'm an architect from Scotland. In Scotland, we speak very fast. Sometimes my friends in the United States have difficulty understanding my accent. And so my wife told me, when I go over there, speak very slowly. But John has only told me I've got 5 minutes, so if I have a stroke trying to reconcile the tooth, please forgive me, okay? I've been here for 2 days. The question is, how do we reconcile neuroscience with architecture? I'm still no clearer how we do that. I've listened to some very interesting discussions. There was one yesterday about invisible invisibility, or a guy with a whale flying around the office. If you guys understood that, well, congratulations to you. I mean, the first question that was opened, the person questioner started with, wow. What she really should have said was, what the fuck? Okay. Tom started this morning with questions that people telephone ANFA to find out just exactly what the organisation's all about. And they asked them, how do you design a school? And I'll tell you how you design a school. You design a school by bringing in maximum natural daylight, ambient light, and cutting out long, dark, featureless corridors. If you do those two things as an architect, you're well on your way to designing a school. A good school. Now, until I designed this school, I had never designed a school before. However, I was interested in the potential of neuroscience in architecture. And that interest started as a young architect a million years ago. My first commission was to do a literature review of the work that had been done on designing physical environments for people with dementia. And that was about 24 years ago or so. And we all like, as architects, to think that architect really matters, that has a positive, beneficial, positive effect on people's lives. But of course, no one ever believes you. But here we have a situation in design with physical impairment, cognitive impairment, dementia, that there was empirical evidence that the design of the physical environment could, it's a regressive disease, eventually you're going to die from Alzheimer's, but the design of the physical environment here was so important that it could slow down the regression. And I thought, well, here we have for the first time, I recognised evidence that actually architecture and physical design was really important. Now, after I had done that literature review, I kind of packed it away. There was no need for me to actually think about it in any other way other than being continually interested in it, because my career took a different career path. But 10 years ago, I was invited to be one of 6 architects pitching for a new job, a school for children who were blind and deaf in Glasgow. They're blind and deaf, they have cognitive impairment, they're all physically impaired, some are in wheelchairs. Together they represent the most physically disabled young people aged from 2 to aged 18 in Glasgow City Council's education role. The other 5 architects who were in the competition had all designed schools before. I had never designed a school before. It was not that, it was that probably got me the commission, and also telling them of my interest in the potential of physical design and architecture to act as almost like a prosthetic effect, to create a kind of sense of independence and self-reliance, but at the same time never putting the children, in this case, at risk. And that's been the theme that's running through the projects on children who have Alzheimer's that I'm working on now. How do you create an environment that caters for the needs of every single individual who might use that building, and children who have Alzheimer's, they can't be uniformly described. They're all completely different. How do you do that? How do you create this kind of sense of independence that promote a sense of self-reliance, but never put them at risk? And at the same time, how do you design an environment for their carers and for their teachers? Because it's a 24-hour, full-on job designing, taking care of kids who have Alzheimer's, who as a consequence of their condition may be aggressive. And that, part of that kind of process is the things that have stimulated me, and part of that is where I think the real bond between architecture and neuroscience had actually come together. What is my role as an architect? Architects are generalists, they're not specialists. You know, I don't really need to know everything about the workings of the human brain in order for me to design a building for children who are cognitively impaired. I don't need to know about the interstitial spaces at Cannes' fantastic Salk building. What I really need to do is bring together all this multi-information, bring it all together in a way that works for the people who are going to occupy the building, but at the same time make it art. That's what my role is as an architect. Okay, thank you very much.
So we have to get you onto this. It's supposed to. Why isn't this reacting? Tech.
It's a tough job you're doing.
Wow, I thought it was here. Oh, there it is. Okay.
So, hello to everyone. I think, and I assume I'm the one in this panel with the worst English. Sorry for that. I'm coming from Germany. I'm in the States since Monday this week. And as you have heard, I'm not a furniture seller or employed by a furniture company. I'm head of this Federal Institute on the Development of Posture and Exercise. My background is I'm a health and kinetic scientist, and our institute is doing research concerning how movement can affect your learning, can affect your brain activities, and of course your health. And in this way we are training teachers concerning how can they transfer their pedagogy, like you can see on the left, that the students are more involved into the learning process. We call this process learning, or the project-based learning, or self-organized learning. The problem is that a lot of parents and a lot of teachers are always thinking it is the best when we send the brain of the children into the school, and the teachers are very hopeful that the brain is coming into the school. But always the entire child is in the school. And when I mean the entire child, it means there is a holistic focus that you have a high interdependency of body, mind and soul. And believe me, the picture on the right side you can see, it's just a picture. And the students do know it is a picture and they behave in this moment by themselves. But during the lesson time, they carry out some really funny things. They are starting to rock and to fidget on the chairs. And this is not naughty, this is necessary. What they are carrying out is what we call, it's a self-organized movement. It's not which is in the conscious, it is a non-conscious activity. It's something what is necessary to maintain the balance of body, mind and soul. Therefore, in our view, it is important that the 21st century learning creates an environment which enables that students are not sitting still the entire day, that students can move around, that they can stand, that they can lie on the floor, that they can change their positions, and that the teachers carry out project and process-based learning. Those are the two columns which are important, that not only the brain is the main focus in education, it is also a focus that there is an interrelationship between body and mind. The background concerning this knowledge we do have today are different researches. The one essential research has been done around about 10 years, and it was basing on a research which has been done with lab rats. They had lab rats in a small cage, and after a quarter of a year they found out that those lab rats in this small cage, no chance to roam around, that all their biological functions were in a significant decline. Also their memorizing. In comparison to that, they had lab rats which have been in a larger cage, and in this cage they had a lot of, I call it movement temptations. They had the chance to balance, they had the chance to climb, and they had the chance to run in treadmills. And they were already active. The activity was very different. But at the end of the research, the scientists found out that the lab rats had a significant incline concerning their biological quality and their memorizing. Now you can transfer this to humans. When you see this picture, you have the typical education situation in the 21st century, in the majority. There are teachers who are talking, there are teachers who are giving informations, and the students are sitting still, not collaborating. And we do know today that the sedentary behavior is the worst behavior we carry out as humans. You are doing the same, but you don't have other chances. And this is a boring and restrictive environment which doesn't really touch the students emotionally. And believe me, there's no chance to learn. This is a typical situation where the brain is falling into fatigue, and when the brain is fatigued, the body is fatigued. And we do know today by a lot of research, if we are sedentary, we don't have any muscle contraction. Muscle contraction are very important, not only as a weekend warrior, at the weekend or in the evening when you're doing a jog. You have to carry out regular muscle contraction, because muscles are not only important to maintain us upright and to move from point A to point B. Muscles are important organs which will release a bunch of hormones and proteins which are responsible for synaptogenesis and neurogenesis in every age, in particular in those, let's say, important 11, 12 years when the brain is building up its infrastructure. We are talking about adolescents. They are not adults. And behind the word adolescence is they are passing a very sensitive and critical period of developmental processes. And the only chance to enhance this process is movement. This has to do with our evolution. We were always active concerning the interrelationship with our environment. Since the last 30, 40, 50 years, we are more passive. And in this way, all this, what we do have a complex system, is neglected. Our biological quality is evolutionary requiring for supplies. And supply requirements, for example, are shown by those students when they are starting to rock and to fidget on chairs. In the other way around, we have options that, due to pedagogy and the design of the environment, students can carry out a self-organized activity. They can carry out postural changes. They can move around and they can collaborate. And this is necessary. This is something what basically is activating our muscles, and all those biochemical reactions have a positive impact on our brain. We call this is an enriched environment. And due to a lot of research, we also know that when we are more physically active, then special sensors in our body are stimulated. When we are speaking about design, we always have in our mind, we do need natural daylight. We do need good acoustic. We do need a good fresh air. But we do have more sensors. We have special sensors which are located in our body, the proprioceptive system, the sense of balance. And if you are sitting the entire time without being active, those sensors are not stimulated naturally. But they do have supply requirements. And you cannot fulfill those supply requirements maybe when you are sending a physiotherapist into a classroom, which will make movement breaks. Movement breaks are organized, but we have to be self-organized concerning movement when we do have individual requirements. And what we do know today is the complexer those activities are, the more they will have an impact on brain activity. Nerve cells which will fire together will wire together. And of course, the more muscles you are stimulating, the more of your proprioceptors will be stimulated. And in this way, you will have a significant impact on your brain. I will give you an example so you can feel it. And I hope I'm still in the 5 minutes.
No, not more. No.
No,
You need to finish in a minute. You're
In a
way
minute, okay.
No, really, please.
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 One example that you really can understand what I'm talking about, because it is one important pedagogic issue. Don't only watch it, don't only see it, also feel it. Please stand up. Now, have one hand on your stomach and the other hand on top of your head. Do surface here and the smooth sitting here. This is not really, for your brain, it's not really stimulating. It's a linear activity. It's not complex, it's a linear activity. And now we have to lift one leg and bring the left into the rhythm of your hands. Now it's more complex. It's a higher motoric coordination. And at least close your eyes. And at least close your eyes. Thank you very much.
Thank you, Peter. Okay.
Now we have seen one sentence.
Please.
Now you have seen the effect when you are stimulating your proprioceptive system. It has an effect on your emotions, you feel better, and on your attention and concentration. You will be more alert for the next speaker.
Thank you, Peter. Lennie.
Something real fast so I don't go too long.
Okay, this is yours, right?
So let me just, don't open it.
Okay.
Hi, I'm Lennie Scott Weber, and I'm a recovering academic. I've been, at this vintage, I'm sort of a long-time everything, but I got an epiphany almost 20 years ago to realize as a designer and as an educator, we have forgotten how to design the formal educational environment. And so today I'm a researcher and designer at a director of education environments for Steelcase Education on a global platform. And the framework that our team has landed on is something we call the active learning ecosystem. So to build on my colleagues before me, it's really very important to think about how do we support active learning in a very passive environment. And I've written for years about the sense of wicked problems that are involved in that. It's not easy. But this Venn diagram is very purposeful in that the pedagogy is at the top. The technology and space are just tools that are sort of subservient, if you will, to that kind of thing. But if you don't have an active educator, you don't have active learning. And so as much as we talk about what kind of space needs to happen, how do we support the children in the environment, if we don't change our pedagogical structure and the way that we support how people actually educate, then we're always running an uphill battle. So some of the observations that we've done, years and years and years of observations, but looking at these kinds of situations and telling us what's going on. So the first part of our research is always sort of social ethnography, really looking at the behavioral aspects of what's happening in these different situations. And then we look at traces environment, so what's going on in the different formal learning environment. We've certainly spent a lot of time looking at more of the informal and library research, but this is just focused on what we call the formal learning environment. And there's sort of a pattern that you can see here with the formal learning environment. And so one of the things that we think about with all of the changes that are happening for education literally across the world is the influx of tremendous amount of technology and change, which I think it should be welcome. But Benjamin Bloom sort of set up this idea in this pyramid about how we learn, and then sort of pedagogically how we might support how we learn. And if you think about it, in something that is sort of in the academic realm today is something we call a blended learning environment or a flipped environment. And what we're looking at actually is, if you think about the lower level of cognitive thinking, that's what you've experienced in this kind of situation, is that it's very passive. When you think about having a flipped environment, the lecture goes home as homework, and now you're coming into the doing environment in your classroom, and it has to be more active if you're going to actually get at the higher order of cognitive thinking. And so one solution, hopefully I do this right, is the way we've taken all of this information and we've tried to generate different kinds of ideas. So our research, there's a tremendous amount of research that goes into the front end of trying, as David Kelly, the head of the founder of IDEO and the Stanford D School, say, what are the good problems to solve? And so here we're thinking about how do you create a dense environment, but you support the analog, the digital, the opportunity to move. So if we look at in environment behavior, which is my specialty, if you look at a classroom environment and you see row by column seating, you know as a student, you know exactly the behavior that's expected of you. And as an educator, if I'm standing up here, I know exactly the behavior that's expected of me. So we always talk about how do we give permission to act differently. One of the major components that we think about is there's 4 vertical walls to every floor plate. So why can't we use the verticality of space to encourage movement, to encourage change, and then to be able to reconfigure? We talk about things being much more in a fluid mode, and so in that process, we've put all this research into the front end of designing an object in this case, or it might be something that we would share in an application setting that we indicate our research insights and design principles that have evolved from that, so that things are evidence-based design. And then the team went out and said, well, does it matter? Is it, you know, how do we measure this? And the focus of our work has been on student engagement. And so several published articles, but the active learning and post-occupancy evaluation was developed by using 4 pieces of the puzzle, if you will, 4 parts to the survey instrument. And then we worked with researchers in Canada to develop a reflective model, or a 2-tiered system of looking at a pre situation as you're sitting in the new, so a reflective process. And then just quickly, I'll share with you that the the old, or the condition to think back upon, was a row by column seating environment, and the new was in any one of these new active learning environments. And so the survey difference, this was published as a pilot study. We have an ongoing 3-year work in different countries and across North America looking at student engagement. And so you can see that there was statistical significance in the engagement factor from students and faculty looking at student behavior and engagement. And then 4 other active areas that were of interest to us was the ability, if you think of Bloom's taxonomy, being creative is one of the higher orders of cognitive thinking, being able to be creative, increasing motivation to attend class, achieve the ability to achieve a higher grade, and engagement in class was both significant from what the instructor's perspective as well as the student's perspective. So in summary, there are multiple different kinds of things that we can think about. Environments impact behavior. That research is well known. Active learning makes a difference. Evidence supports decision-making in terms of having an active learning environment, and it takes more square feet or square meters per person in order to move to learn. That's a tension with registrar's office. Pedagogy is really important, and it hasn't caught up, and there's more skid marks in the tile for faculty like myself to change than you'd care to admit. And I think we owe our children that. So we have 21st century learners in 20th century teaching practices, in 19th century learning places, and evidence-based design, in our view, makes a difference. So thank you.
Peter Barrett. You have one. You have
display thing at the bottom.
There you go.
Okay.
Right?
Yeah. Thank you. Good afternoon, ladies and gentlemen. So I've only got one slide, but it has got several layers, so I think there's a bit of a cheat going on there. I'm going to tell a very quick case study of trying to take some broad ideas through to some results and trying to fill that gap between lots of very focused studies and the holistic experience and impact of spaces. So what I'm showing you there is a conceptual model of different research approaches. On the left-hand side, there's microscopic studies where you can control the variability and you can essentially just fix everything except one, and you can do this in a laboratory. On the right-hand side, there's stuff out there which is uncontrolled and you're trying to understand it and you can do case studies and things, but it's very difficult to actually make sense of what's going on in the same sort of way. And you would imagine that you can just move across from the left to the right by being cleverer and cleverer and having more and more computing power, and wouldn't that be great? Well, I think it's actually completely impossible, personally. And I put a figure in there just as a very practical example. That figure there is saying for reinforced concrete, the factor of safety that people use is 2.5. This means, from the codes and all the very accurate calculations they do, they come up with a number, then they multiply it by 2.5. Just in case, for snow loads, for variability in the material, for funny uses and all that sort of stuff. So basically, 60% is unknown and they're just making a guess. So this gap is really, really big. And the idea behind this particular look at research is to say you have to jump up a level of resolution. You have to conceptualize to be able to join those two domains. And if you do that, you can make a bridge. If you don't do that, then you get into the reductionist nightmare of trying to get more and more across from left to right and almost certainly failing. So in the top part there, there's this higher level of resolution. We've tried to take a lot of research that's been done in the laboratories, case studies that have been done of real-life situations, and link them by a conceptual model that is neuroscience informed. We've done some terribly rough things with neuroscience. There's lots and lots of detail. Fortunately, I'm not a neuroscientist, so I don't feel compelled to follow the detail all the way. But I did read some very big books, and I ended up thinking, so what's the simple structure that's sort of implied by this? And came up with a proposition of 3 main elements. One would be naturalness, primary reinforcers. We're animals, we like certain things to do with health. Secondary reinforcers to do with individualization. We all learn, we all have individual experiences, and so we have individual preferences. And the third thing would be behind all of that, there's the level of stimulation that's going on that's appropriate for the situation we're in. Are we trying to concentrate? Are we trying to be excited? Are we trying to rest? Or whatever. So 3 broad principles, which we then use to structure the multiple factors that are out there to be considered. I'm skipping through this very fast. We then tried to say, well, where could we apply these ideas? And the place we decided upon happened to be schools. I'm not obsessed with schools, but primary schools are a brilliant thing to study because the children spend almost the whole of their time in a particular classroom, and there are metrics of how they progress in their learning. I know the metrics about learning aren't the only thing to do with education, but they are very tangible and they matter an awful lot to the people involved in education. So we set up a project to try and understand the effect of the holistic environment by structuring various things using those 3 principles and linking it to the results for the children in the schools. We've now looked at 153 classes in 27 schools, 3,766 pupils, and we have data for each of those individual pupils and which class they were in and what the characteristics of the physical characteristics of those classes were. And then using multi-level analysis, it's possible to actually try and strip out the various impacts. The model for the research looks like this, with all the built environment things on the right, impacting on the pupil. We've got the pupil at the centre of the model, looking out and being affected through their senses. We've got the pupil's performance going up from the bottom to the top. We have their starting position, their ending position. That tells us something about the pupil as well. On the left-hand side, we have a whole load of non-built environment things like the ethos of the school and various factors like that. We've published our initial results from phase 1 in building an environment. This is a horrible thing for people who publish in that journal because they look at heat, light, sound and air quality. And we're saying, but there's a whole load of other things. And it was the best paper in 2013 and it was the most downloaded paper in that journal. So all credit to them for actually saying, well, maybe this is an interesting thing that's going on. This is a preview of the results on the much bigger sample, 5 times the size. We haven't published this yet. It will be published by the end of the year. The green things are the naturalness things, the blue things are the individualization things, and the red things are the level of stimulation things. They're very practical dimensions of the design environment. In the multi-level modeling, the things that actually come out, so this is where they all are actually acting together in the context of the individual pupils, are those listed there. I haven't got time to say anything about them, except some stuff comes out, and at the bottom there, we can model their effect, and they account for 16% of the variation in learning of those 3,000, however many it was, pupils. 1 minute. I think I might be almost there. Yeah, last slide. So I would suggest just a few dimensions that come out of the analysis. Spaces, not buildings. What we found is that the individual spaces are much more important than the overall building design. We spent about 6 months trying to get measures of the overall building to actually come out in the model. They don't. There's not enough variability at that level that relates to learning in progress to actually discover it or to be able to make it come through. And so actually doing an inside-out design from classes that really work and then hang together, of course, as a good design seems like a good thing. We're talking about users' needs, not users' wants. We spoke to a lot of teachers, a lot of pupils, but in the end, we feel they could all be informed by some of this information and it may be helpful. They don't always ask for what's good for them. No, they're not given an instance, we haven't got time. So my particular thrust is to try and make this connection between the industry, the designers, the construction sector, and people, and actually satisfy their needs, together build a better world, make it evidence-based design for clients and for constructors, and in that way, I would hope that we can actually do better construction, we can create better buildings, we can actually have a positive impact on society. Thank you.
Thank you, Peter. Karen, would you care to add some words?
Hi, I'm Karen Dobkins. I'm a visual neuroscientist, and I did my PhD here at the Salk many years ago with Tom Albright, studying visual responses in monkey visual cortex, trying to understand how different parts of the primate brain allow us to see things like color and motion and integrate them. And after I finished my PhD, I got a job across the street, so I'm not here anymore, at UC San Diego. I've been a professor there for almost 20 years in the psychology department. And I switched from studying one ornery animal, that is, studying a monkey is very ornery, it's a lot of work, to studying an even more ornery animal called the human infant. And so I moved my area of study to visual development in human children. infants and children all the way up to adolescents. And I've been doing that work for a long time. Just to give you some understanding, if you don't know much about visual development, babies are born seeing the world very differently than adults. Just to give you a sense, their world is very desaturated in color, very fuzzy, as if they weren't wearing glasses when they need them. And it takes time for them to develop that sensitivity that adults have. In addition to studying visual development in typical babies and children, my lab also has been studying children with special needs. And the two that are most relevant to this panel that I'll tell you about is that we study children with autism, and probably you know from some of the speakers today and yesterday that kids with autism see the world differently. In particular, there's a lot of talk, and Temple Grandin has given a lot of emphasis on this topic in her most recent book, which is that children with autism have unusual sensory experiences. They often seek out extra stimulation, like aligning things perfectly, or some of you know about kids with autism having this thing called stimming, where they flap their hands in front of their eyes. And we think that part of the reason that they're doing that is to give themselves stimulation. They're seeking out sensory information. That's one flavor. Another flavor is that some kids with autism are sensory avoiding. They really don't like these lights, or if they're flickering, they're very sensitive to those lights. Some kids are very sensitive to noises like vacuum cleaners and airplanes going overhead. And so we've been studying the sensory processing in kids with autism, starting from babies, from when kids are even just at risk for developing autism. The other special population that we work with are children who are deaf. Who we're also learning, we've been studying them for many years, see the world differently. It makes some sense that they would see the world differently because they're missing one of their senses, audition. And one of the things my lab has found is that part of the reason why people who are deaf see the world differently is because their auditory cortex, which isn't being used for audition, because they're not the type of deafness that we study is a problem with the ear. It's not any kind of central damage. So these people have a perfectly normal auditory cortex sitting there, but not getting any input from their ears because there's something wrong about the development of their ears. And so what we've found is that their auditory cortex instead comes to serve visual processing. So if you do an fMRI study, we've done it with fMRI, we've done it with MEG, you find that visual stimuli, in particular, visual motion stimuli, activate their auditory cortex. And we've done a lot of perceptual studies in deaf individuals, also showing that they just see the world differently than the rest of us. They see things moving in a different way than we do, and that's partly because they're deaf, and it's also partly because they use a visual language which is spoken with the hands and perceived with the eyes. And there's a lot of motion in sign language, and the motion of signs actually provide important linguistic information for any of you who know sign language. I also meant to tell you that people who, kids with autism, another way they see the world differently is oftentimes they see things as brighter than they actually are. We've done the perceptual studies to show that they actually see a light-dark stimulus as having more contrast than a typical individual. Kids with autism also have trouble, this is stuff from work from my lab, discriminating between different faces, but they have a superiority in discriminating between different objects, like between different toys or different makes of cars. So their visual sensitivities are very different. Okay, so that's in way of background, what my lab does. And now I just want to tell you in the last couple of minutes how I got started in my interest in the interaction between architecture and neuroscience. And it happened about 12 years ago when I got commissioned by a Japanese company to design visual interiors for condominiums in Tokyo. And they said, look, you're a visual neuroscientist and you study development, so come up with interior designs for infant rooms and children rooms that will help promote their visual development and help improve or promote well-being. And so we came up with this idea called tailored visual environments that is based on what we know about the visual sensitivity of infants being poor, and so designing things to be particularly visible to those infants, and also based on the idea that in children, different children have different temperaments and need different types of stimulation. So we had questionnaires that would assess whether a child was particularly, let's say, negative in their affect, in which case the designs in the room would be designs that promote positivity based on research that's out there about what colors and designs promote positivity. And so that was the first thing that happened about 12 years ago. And then I heard about ANFA, and I gave a talk here 2 years ago. I wrote a paper about the work that we had done in Japan, and that garnered some interest. And now I've got another project going with my colleague Roy Verbakel, who's here, who's a designer in Belgium, where we're designing daycare centers in Belgium, again, based on principles of what infants can and cannot see. The next stage is to bring these designs to special needs populations like kids with autism and kids who are deaf based on their specific visual sensitivities. And so that's my excitement about this work. Thank you.
Thank you very much. So what we'd like to do, we're now at 16:04, and I think I'm supposed to stop at 16:25. We have some questions we'd like to ask of the panelists, and then after Tom and co lead some closing remarks, and some of you are going to choose to go on a tour, but we are going to continue with a roundtable discussion. And we thought actually if there are still tables out there that we will move out of this space and sit together in a more informal way so that people from the audience can ask questions directly of our panelists and perhaps share some of their own experiences. Where is it? I've got it hidden. Oh no, it's here. Oh, wait a minute. Okay. It's not up? Is it, can someone cue this thing? It's, there we go. Okay, I'm going to start with the first question, which is a broad one. And this is for anybody in the panel. There's a quote, actually, from an article about the Hazelwood School by Alan Dunlop, that supports this question. What problems were you trying to solve? What outcomes were you trying to achieve in your various projects? So I'm going to ask Alan to start off with a specific response to that, and will the others please join in?
Is it possible to put the slide of the Hazelwood project on the screen? Is it possible also to turn out those, not only am I going to have a stroke, but I'm going to have... What problems were I trying to resolve? I'd never designed a school before. Certainly I'd never designed a school for such potential user, children who are dual sensory impaired, blind or deaf. I won the project in competition. I was the only architect never have to design the school. The only architect never have designed a school before. As it turned out, that was beneficial because I came to the project without any preconceptions. And it also turned out that no one else had designed a school for children who were blind and who were deaf. And architects usually, when they start a new commission, the first thing they usually do is look for precedents. What have other architects in the world done faced with such a programme? And it turned out, to my complete surprise, there were none. So it started in an 18-month collaborative process. I'm all for collaboration as an architect. I know that's a fundamental part of how it is we work today, as long as people do what I say at the end, right? But it was very important as part of this process because I had to completely understand, or as far as I could, the needs of the children and their parents and also the teachers, but the clinicians. The most difficult people to work with in that whole 18-month collaborative process were actually the clinicians, because they were dogmatic, right? And if I had to listen to everything they told me as far as what had to be included within the building, I'd still be designing the fucking thing right now. I had to stop and use my 25-year experience as an architect to tell them, or for me to decide what was important and what wasn't really important, right? The overarching ambition behind my design was that the idea of, I said before, bringing in maximum levels of ambient light, cutting out long dark corridors, but the idea that the building could actually act also as a sensory and visual cue. So throughout the building there are a number of audio and cues on the floor and tactile cues, also in the sense of materials, which gives the kids the ability to be as independent as possible and to get around the school with their own kind of self-reliance without everybody having to be on their shoulders and guiding them through. And as a consequence of that, reducing the potential of them getting angry, because it's autism and children who have such complex special needs as a consequence of the condition can sometimes get very frustrated and they can sometimes get angry. And it was trying to ameliorate that as possible, to promote this sense of independence and self-reliance, to make them able to go anywhere. How do I get there? It's easy for me to get there. But also design a building. Whenever I talked about this the first time to architects, and I talked about maximising natural light and also giving a connection with the landscape beyond, and allowing people to perceive the seasons, they would ask me, well, the kids are blind, what's the point of doing that? Right? And the point of doing that is that they are aware, they can take in the change of the seasons, they know when it's raining, they know the kind of different pressures, what's actually happening, what's happening outside. But the other important thing is that this is also a building for the people who teach and who work there. Because I said during my very brief 5-minute presentation that it's a very hands-on, very difficult job taking care of these young kids. So what was I trying to achieve? I was trying to achieve a building that worked for not only the kids, the 2 to 19-year-olds, blind and deaf, severely physically impaired, one that their parents would be happy with to send their kids along to, one that would satisfy their clinical needs, and the other thing which was incredibly important, the building was set within a parkland setting that had been a park for 100 years, and I had been there a number of times before we had started designing. It's within a residential area in the outskirts of Glasgow. And the time I'd been to visit the park, no one had been there. There was not even anybody walking their dogs. But as soon as people knew that there was going to be a school there of some size, it became the most important green space in the whole of the south of Glasgow. Right? So try and satisfying the amenity of the residents and trying to assure them during that course that what I was trying to do would be sensitively integrated into the parkland setting. And as far as possible, create a school which had a relatively big footprint, but had a minimum impact on the site. So there was all these kind of things.
I'm wondering if, Karen, you might want to join in, since you have been looking at specific needs environments from a different viewpoint, from the viewpoint of a neuroscientist.
Right, well, we haven't actually designed anything for the people with kids with special needs, but that's our next step. But the idea is, again, like I said in my little intro, that you first have to understand what people are perceiving, and then you need to create an environment that best complements their vision. So, for example, the simplest one is with little kids who can't see high contrast colors very well. It's a mistake, people always buy their niece or nephew like a little stuffed animal that's pink, or like light blue, but that's not something a baby can see. We know that from research in my lab. So you want to actually present them with stimuli on the walls and the design of the building that is visible for them, because we certainly know that infants who are deprived of vision don't develop normal vision. So the idea is to give them an enriched environment. And then, like I said, the next step is when you work with the special needs kids, you want to know how they see the world so that you can create an environment that best complements their visual sensitivities. Yeah.
Anybody else like to add? Peter?
Our motivation was quite simple, really, which is that we'd done a lot of work putting together a lot of existing information. We'd presented it to real clients, and they'd basically ignored it because the planning regulations or the cost or the time or something else had got in the way. And so we thought, well, the only way we're going to get any traction on this is to link it to something that really matters to them, which is progress in learning. And that was thought to be a hard thing to do, and it turns out it hasn't really been done broadly. The impact of holistic spaces on human performance is quite an underdeveloped area in a way. People have looked at different dimensions, and so this is an area where I think neuroscience has a lot to offer, because of course the brain does that gathering together process, and it can actually give us analogies for how to try and make sense of the physical complexity of spaces. That's our feel anyway.
So, from my point of view, the biggest hindrance we do have concerning convincing people is when you talk to people, it is important that let's say humans, not only children, have an environment where they are enabled to move. They will tell you, okay, there's another guy which try to explain that movement is important for your physical fitness. I think there is a big difference concerning movement. So this quality of movement we are talking about is not physical exercise or sports-related movement. This quality of movement I was talking and we are trying to talk about is that movement is a basic need. Movement is a basic need like eating, drinking, sleeping, social interactivities. So you have to move. We have moved for millions of years, and this complex system, what we really achieved today, this complex system really is not prepared for an environment where you are restrictive. And when you are in an environment which is so restrictive, then your body, mind, and soul balance is getting out of balance. And it is not only that we are flexible in environment concerning having equipment in the classroom which moves from point A to point B. It is that we have to move, that we have to stand up, that we have to ambulate, that we have to collaborate with others while we are moving. When we think 1,000 years ago, the students of Aristotle, the Peripateticus, they were called Peripateticus because they had walking halls and they were discussing in walking halls. They were moving around. And even when you are, for example, working on your computer and you are working on a concept and you got stuck and you say, oh, let's stand up, let's get a cup of coffee. When you move to your cup of coffee or to prepare your cup of coffee, all of a sudden you have the idea. So we do need spaces and acceptance that we can move around when there is a supply requirement. And by the way, how do you think, or what do you think is important for your brain to be attentive, to be concentrated, to be focused? It is nourishment. And what is nourishment for the brain? It is oxygen, it is proteins, it's hormones, and all those components, proteins, enzymes, hormones, are only be released when you carry out a self-organized movement. And this self-organized movement is a non-conscious movement. It is in reaction when there is a special supply requirement. And this is really hard to convince people who are decision makers, people who are teaching, and believe me, sometimes also architects.
In terms of outcomes and design decisions, we ask our panelists to consider this question as well. What was your design response and what informed your design decisions? Some of the things we've discussed already clearly are in that bucket, but the physical environment has a big impact on student behavior and engagement in their learning process. A quote from Lennie, and wondering if you'd like to comment on this as well?
Sure. I think one of the issues that we've looked at for a long time is that we are, in essence, as many authors in this last few days have said, a big portion of the brain looks at pattern analysis, and sort of that is our way of understanding, in my simple terms, not the neuroscientists on the board. But so if you think about the pattern, as I mentioned in my talk, that the pattern of understanding what is the behaviors that are expected of us, if you look at the seats, for example, that you're at, if you don't know the person, you've probably put your bag or your coat or something next to you, because in this auditoria, as another author talked about, E.T. Hall in his theory of proxemic zones, we invade our intimate privacy zone here. And so you start to set up a fight or flight syndrome. So that whole behavioral component is really important. If you, again, think about all of the designs that we've done forever, saying what is the capacity of your academic building and how many classrooms do you need? And we often have a template. As architects and designers say, okay, we've got a template for that, now let's go do the fun stuff. And I'm often saying, no, we have to stop that. as either one of my colleagues or someone today said, it's really important to think about that interior place for the formal learning environment first, because that's where it's orchestrated, that's where it starts. So thinking about the behavioral response when you open that door to encourage and give permission to act differently, to stand, to move, there's sort of a thinking about posture and place and how place supports the thinking about what we need to do for posture. So,
Alan, would you like to comment on it as well? I mean, we're talking about objects and objects in space, the spaces themselves, decision-making.
Places, objects in space. I don't really have anything further to add.
Well, okay then.
Well, let me just,
Sorry,
wait,
I could sing or something.
I think, well, we'll come back to you. There'll be another question that maybe we can cue you on. This is a question which I think maybe we'll let Peter start off with. What are the challenges of the research you're doing or have done? How have you determined, measured, and assessed the success of your design work or your research work? Peter, you have probably worked on the most extensive study. Can you talk about outcomes? I think there have been challenges as well as achievements in that research. Do you want to comment on that?
Yeah, there were challenges. The success was that multi-level modelling worked better than we expected, so we were able to identify stuff to do with the individual kids and stuff to do with the groups of 30 children in particular spaces and the variation of learning that went with those. We were disappointed because we couldn't actually get it to work at a school level, but then our statistician pointed out there just wasn't much variability there to find, and that was why. So that was quite obvious when she pointed that out. We had difficulty with some of the measures. So the sample size went up a lot from that published paper to the one we've now got. Some of the variables changed, and that was quite shocking how volatile the data was, but now it's a very big sample, so I think it should have stabilized. I haven't got time to describe our methodology, but I'm going to, because it's actually I'm not going to here, but I'm going to publish on it, because we've actually used what is effectively a grounded theory model, which is a truth-seeking model linked to a hypothesis-led model, which sounds like a complete contradiction, but it's a cyclical model where we start with hypotheses, but it would be ridiculous to ignore what the data tells us. Mm-hmm. And so that was one of the very interesting things. For instance, we thought visual complexity would be good for stimulation, and it turned out that actually, because we had enough data, we could plot each point in the scale against changes in learning. It's curvilinear. And you need a middle level of stimulation, which of course the moment you know that is quite obvious, because it could be chaotic or boring or perhaps just about right.
We call that the Goldilocks effect.
yeah.
Seriously.
I mean, but we got it wrong to start with, so it would have been ridiculous as well for us not to reconsider the hypothesis. So we used that to create a new hypothesis, which actually, if you like, made sense with what the data was telling us. So I think there's an interesting process there that we came against, and we worried about it because it could seem like fitting your results to the data. That's the worry. So we decided you had to make it very explicit and actually show those individual steps. So lots of challenges, but I think we learned some interesting things on the process, and we'd like to share those.
Karen?
Can I say something about Peter's work? I really like it. I mean, I don't know if everybody fully understood it. I mean, just because, it's very, very sciencey, but the idea is that, you don't actually manipulate the situation. You just take data from natural environments and you see what correlates the best with good grades, right? And I don't really know anybody else who's doing that. And it's just really interesting to think that most of us, myself included, are coming in from the other end, where we're manipulating environments and then we're seeing how people do. And I don't know which way is best. I mean, I think they both will inform the question, but it's just really interesting to think about doing more of the kind of stuff that Peter does, which is looking at existing situations, not manipulating, and then doing this, multivariate analyses to see what correlates best with outcomes like mental health or grades. It's really cool.
And hopefully meet in the middle.
And, yeah,
I was going to suggest we have a few minutes left. Would anybody from the audience like to pose a question?
Is there anybody else doing what you're doing? It's really cool.
Do we have mics?
Makes a lot of sense. I mean,
There's a mic.
I wish they would assessments too. We can talk about that. Okay.
Can you hear me? Yeah, the variety of perspectives in this panel. It's fascinating. I'm surprised no one mentioned digital content.
Sorry?
Digital content. Is it too early to talk about so-called augmented reality or mixed reality in the classroom?
What were you saying, Sergey?
Digital content, mixed reality, where you bring in digital representations of whatever is relevant to the class.
Can you give an example? Yeah, give an example.
Movies. Not shown as a part of curriculum, but having dynamic content present in the classroom at all times.
Can I? No, is the answer to that. That's not architecture. Sorry, but it's not. All right. Listening to Michael's lecture this morning, and very interesting as it was, if you need a digital floor-mounted display to tell you how to get out the building, well, the architect's mucked up there. All right. There's no, and what did you describe it as? Fast. What, the same as your telephone. What is it called? Speed architecture. Rubbish. Okay. These are all diversions for real architecture. LEED. I've seen many great buildings, great school buildings. Some of them have LEED accreditation, which is fine. I've seen some of the worst school buildings I've ever seen, and they're LEED gold standard. These are all divergents to architecture. These have really no place as far as how you create something which is a stimulating, pleasurable, workable, delightful, brilliant place as a piece of architecture. They're all secondary issues. Sustainability, the big S word. Architects who are really good architects have always known about sustainability before it was categorized as sustainability. The appropriateness of materials, the longevity of the building, a building which is suitable for purpose. Digital animation doesn't come into that. That's not architecture. That's got nothing whatsoever to do with architecture.
Could I just add, I mean, I don't really disagree. At the moment, there's not a lot of it about, but we do actually, for instance, know some people who are teaching history with completely immersive environments and have had great success in that from a pedagogical point of view. From my point of view, longer term, if you see the environment as the third teacher, as something that can be manipulated in a smart way within the building, knowingly by the teacher and used as a part of their pedagogy, that would be a good thing to aim for, if it was done knowingly and if it was done with some sophistication. But it may not be architecture, but it may be teaching. It may be learning.
May I just throw in a little anecdote? I know I'm not supposed to be saying anything, but the Crow Island School, which we cited earlier on, interestingly enough, included immersive environments. There are rooms that are set up for pioneer days where you could go and be in an environment and pretend you were a pioneer. They were furnished spaces, so they were non-digital, but they were the precursor of immersive digital environments. I think, though, the interesting thing is that the fundamental structure of the building, its qualities of light and planning and so on, are the things that are still very effective. The school was built in 1939, and it's still, in a way, a modern school. So I think probably one of the questions is, what is the lifespan of the immersive environment? Is it something, presumably it's something that's always evolving.
I think if I could just add, if you look back at Reggio Emilia or Montessori in the beginning of this century, and particularly Reggio Emilia, the concept was that the environment is the third teacher, and I know there's been other books written about that, but it's really about helping the student understand how to navigate in their environment, but what the environment can, the influences the environment has upon them as well in their learning process. So it's at least 100 years old, and I think it has a great premise and a great grounding in what we should be doing for education today.
Could I say one thing about the computer and digitization?
And then I'm going to interrupt you.
I mean, I also teach. It's one of the saddest things in teaching is that my students can't explain to them the most simplest of architectural ideas without reaching for their laptop. The computer, which is invented as a tool to assist creativity, has now become a kind of method to replace it. So my unit in School of Architecture don't allow computers, no computers. Everything must be hand-drawn. Or they make a model. For the students that have a phobia against hand drawing, they have to model make, no computers.
I think it's important to mention, too, that in an example like Montessori or a Steiner school or Waldorf or whatever, the wild card, which is pedagogical piece, is stable. And when you're talking about a public school or a school where there are a variety of people who are not all of the same mind when it comes to pedagogy, that's a huge wild card in the design of the school. And that's why we were showing some of the images of a school may have been designed for one thing, but the teachers are blocking the windows and building walls and isolating themselves, because in teaching teachers, I can tell you there's a preconception about what teaching is. And breaking that preconception is very, very hard.
One last comment, because I think we need to turn the floor back to Tom Albright.
Yes, another comment concerning our digital world. Okay, we are living in a digital world and we are evolving, and I think we cannot understand that there will be a future without technological consumptions. But there's also a warning, because we don't have any research how the digital world will affect us. But there's one recent research, and they found out that more and more young people are short-sighted. They are short-sighted due to the digital world. And they have also found out that when they have the chance to live in a way like they are used to live, that they are playing in the schoolyard, that they are romping around, that they have a distant vision, that this has a better performance concerning the developmental process of the eyes. And this is what I try to explain. We have to bring it into balance. We have a long history behind us. And we have just 30, 40 years where we are exposed to multimedia consumptions. And we should not forget where we are coming from. And therefore, it's not a warning concerning that we are increasing a digital world, but we have to balance it. We have to balance that, what we are coming from, into and bring it into balance where we are now, in the present and in the future.
Tom, can we have one more question from the audience? Is there a microphone for this gentleman here?
Going back to the digital immersive environments, I think so it could be very valid for spaces for special kids, like where we have the snozzling rooms, like, where they can experience the environment as environment being the third teacher. It can be in terms of anything that's been displayed on the walls, on the floors, in terms of patterns, colors, where they move, respond to. That can be very effective in these specific cases, if you look at that as well.
Is that a question?
Does anyone want to comment on that?
I didn't understand.
I think
I was actually talking about the snozzling rooms that are being designed for special kids with sensory problems, where there's a lot with the digital.
Karen, I think maybe the question.
I couldn't hear the question. I'm really sorry.
I think the question is there a place for a digitally sensitive environment, a responsive environment that may use surfaces in multi-dimensions to respond to the human condition? Is there a place for that?
Yes.
You see potential for that?
I mean, of course there is. You have to be thoughtful about it. Yes, of course there is.
Yeah, especially the one that we see with the snozzling rooms, that's what I was wondering.
Okay. I think, Tom, I know that we were asked to be done by now, so what I want to again remind you is, for those of you who don't wish to take the tour, we are going to continue this discussion in the foyer, And the panelists will be available for the next half hour or so, or 45 minutes. We'd be happy to continue the discussion there.
And let's thank again the panelists and the moderators. I just have a few final comments, most of which are just thank yous. The interface between architecture and neuroscience is a very big space, clearly, and we've covered a lot of that space in the last 2.5 days. We've learned about new technologies that are relevant to investigating that boundary. We've heard about architecture and the senses, architecture and emotion, and the practical applications of information that's been derived from the field of neuroscience to architecture. And and we've heard lots of different perspectives on this. And for me, the most rewarding thing about it, the most satisfying thing about what I've heard in the last 2 days is that we're starting to move in sync. We haven't got all the connections, as Michael so rightly pointed out this morning, but we're starting to develop a common language. We're starting to understand one another. We're starting to understand the methods and the constraints and the desires of each of these different communities such that we can work together. This is, we've been moving in this direction for a decade now with this academy, but I think that we're now to the point where stuff is starting to happen. And this is a very good thing from my point of view. And there's many people I want to thank, but in particular I want to thank all the speakers who took their time and effort to come to this conference and present to us, and their thoughtful perspectives and the willingness to sort of reach across that gulf and try to develop a new way of thinking about things. This has been incredibly important. So let's hear it for the speakers. And also, as you can imagine, organizing a conference like this takes a lot of effort on the part of lots of people, and I want to thank the members of the board of ANFA for all their time and devotion to this. There is a conference organizing subcommittee of the board, and I spent a lot of time with these people over the past several months trying to pull the pieces together. There are a couple of notable people that were really helpful along the way. One is Betsy Doherty, who was the head of the sponsorship development group, and she did a fabulous job making this possible by raising funds to support us. Fred Marks, where's Fred? Fred's in the back. Fred is our treasurer, and Fred was invaluable at multiple stages along the way in sorting out things. He's really good with contracts and that kind of stuff, which I'm not so good at. He's very meticulous, and this is good. And there are other people many other people on the board who contributed to this. The advisory council, I contacted various advisory council members along the way, getting advice about what to do. Claire and John, who have disappeared, oh, there they are. Claire's actually on the advisory council. I got to know John about a little over a year ago through my connection to the AIA. Well, I was invited by John to go to a meeting in Boston, I think it was. The AIA Committee on Architecture for Education, and this has been a really important connection for me personally, and I think for ANFA more generally, because it's such an important problem, as we've heard this afternoon. And so I want to thank them for taking over the leadership of this session this afternoon. Another person related to ANFA that I want to thank is, who has been absolutely invaluable for all of this, is Hannah Hobbs. Where is Hannah? Is Hannah here? Oh, Hannah's, there she is. So as I said on the first day, I can sort of handle the intellectual content, but I can't, there's so much stuff that goes into organizing a conference like this, and a lot of it just went right over my head, but Hannah was there to catch everything and make sure this worked. And in my opinion, it worked really well, so I'm very grateful to Hannah for all that effort. And there are, I mentioned this on the first day, but I want to mention it again, there are a number of people who have helped us
either financially or in-kind donations that made this possible. And I want to make sure that you know who they are once again. There's the New School for Architecture and Design, this is the San Diego School of Architecture downtown, which many of our board members, that's not true, not many, but some of our board members are connected directly to the new school, Gil Cook, for example, and they've been supportive of us for many years. I mentioned last night Julia Brown. Julia was at the meeting last night when Peter and Jonathan spoke and John Eberhard spoke. She's connected to Eli Lilly, which was the pharmaceutical company that helped produce the original polio vaccine, and they were very generous with their sponsorship of this meeting. A-Light, the architectural lighting company, helped us. Steelcase, Lennie is here representing Steelcase, and they were extremely generous in helping to support this meeting. Mechanoshade, the window covering company, supported us, and Angelus Block, and Olson Vranas Design and Build. And we had in-kind donations, in-kind contributions of time and effort from TW2 Marketing. As I mentioned last night, Bastian Buma from AIA San Diego was extremely helpful in getting the word out, and the AIA Academy for Architecture and Health and the AIA California Council, all of whom were very generous with their time and effort. Matt Smith, I mentioned Matt Smith before. It's a shame Matt's not here. He had another commitment this weekend. He's been connected with ANFA for many years now, and he's the person who devoted his time, and I imagine I've never done this before, but I imagine it's kind of a tedious thing to arrange for the continuing education credits that many of you were able to achieve by coming here. And so that was extremely valuable to us. And Kate Mears. Kate Mears is somebody who has had a long connection with ANFA. As I mentioned before, she's a practicing architect in Denver, and she's very good with graphics, and so the wonderful graphics that you see up there and on your program were all the beautiful work of Kate Mears. So the last thing I want to do is thank all of you for coming. This is, as I said, we're moving in sync now, and having this kind of audience with this kind of enthusiastic participation is what will carry this forward. We're going to change the world, and we're just at the beginning right now, and it's through this kind of group and this kind of interaction that will be possible. And so I'm very grateful for all of you for attending, and I'm going to turn things over to Gil now, who will have some final comments about where we're going, because we're going to do this again.
Tom, I think the greatest thanks goes to you, not just for the last 2 years, but all the years you put in helping make this organization be what it is today. And just to remind you, you have another year as president, past president to serve. So
I have 4 months.
we'll try to make it more.
You missed this, Tom, but it's really well. I can't do that. I only have one question. Does this help grow hair?
Not really. It's very counterproductive for your hair, as you can see.
I'm going to have a few remarks. One of the things that came up today reminded me of something, and that was when my first son was maybe 8 or 9 years old. I had the discussion that fathers have with sons. Should he be an architect or not? So I sat down to talk to Jason, and he looked at me like I was crazy, and he said, Dad, I would never become an architect. I mean, it takes you 2 years, 3 years, 5 years to see something happen that you've done. And I agreed, and I asked him what he wanted to be, and he said a chef. Instant gratification. He became a musician, which gives you constant gratification and occasionally more. But that was good. But I was only reminded of that because when Allison referred to the first meeting that the Quartet of Architects had here at the Salk to meet with a very august group of renowned neuroscientists, and we were all very nervous. going to that meeting about this thing called ANFA. And it was sort of like a high school prom where the boys sit on one side and the girls sit on the other. But by 5 o'clock we were dancing, and we still are, and it's wonderful. There's the heart's beating, we're doing well, and it's all to the work and effort of the people on the board. I can't name them all, but to you all to be coming to these conferences every 2 years, and what we're looking forward to in the future with more conferences. You know, creativity is a patient search. Rusty Gage said to us at that meeting, you know, it's going to take you, a lot more than 10 years to accomplish anything. Well, this is the 11th year. So he was right, and as Tom said, we have a lot more to do, but we've got a really good start. Michael, will the brains of buildings or buildings with brains elevate the status of plumbers and electricians? Or will we have to have new people to take care of them? And Sergey, I just appreciated the discussion we had at lunch discussing the measurable quantities of things and how it's important in our research. We all look at this carefully, but we have to be careful with things we measure in statistics because, as Stephen Wright, who was quoted earlier, said, half the people you know are below average. Can't argue with that. Doesn't include anybody in this room, by the way. And Johanny, I just want to thank you again for being with us. It's the second year in a row. He was at New School last year for 3 days and reminded us that we must stay on course and keep a very, very open mind and keeping our eyes on what we're doing all the time and being true to ourselves. I always tell our students who use the phrase that's not used often anymore, but do we think inside the box or do we think outside the box? And I've always told them, just build a new box. And that's sort of what we're doing here. And I look forward to expanding what we're doing in the coming 2 years, working very, very closely with the other schools and colleges and universities to expand the network of people we're working with, to share our combined knowledge and experience, and to exercise enough for us to all continue learning. Thank you very much.